Hey, I'm Tim and I work on Emil's Lighthouse project Smart Garments. In this project, we have developed a thermal and haptic interface designed to create immersive VR experiences by stimulating the senses of touch and temperature. We have created a hardware-software infrastructure featuring a modular, wearable and flexible system for vibrotactile and thermal actuators. This includes the design of electronic components and PCBs, garments and textile structures for wearing it tightly on the body, an open API and control system that seamlessly integrates with VR game engines such as Unreal Engine. On the experience side, we have focused on achieving liquid thermal sensations like the feeling of wet, hot steam and cold water. These are showcased in our model VR experiences, a traditional Finnish sauna. Right now, we're conducting user studies to evaluate the wearability of our system and the haptic experience.
Hi, I'm Andy Schäfer from Filmakademie Baden-Württemberg. Emil's Lighthouse project Fate of the Minotaur, a location-based VR experience built with our open-source tracer framework. The experience lets players step into the roles of Athenian sacrifices, navigating King Minos' labyrinth while uncovering a tragic tale of guilt and family conflict. One of our key goals was to create a game that can be experienced in different scale options. Today, we are proud to see our work reaching TLR 8. In one of our latest tests exploring synergies with other Emil Lighthouse projects, we integrated UPF's AR Magic Lantern, enabling users to explore story highlights outside of VR. Walking past the wall, they will pacify Ariadne and the Minotaur, an ideal addition for pre-show experiences targeting broader audiences. As our project nears its end, our focus turns to fine-tuning while investigating possibilities to integrate with other partner technologies, like Aalto's wearable interfaces simulating thermal effects like heat and cold.
Hi, my name is Christoph Lutteroth, and it's my pleasure to announce that the Reveal Research Center at Bath is releasing a virtual reality Exergame that you can download and try yourself. It's in the SideQuest store, and there's a free version and a paid-for version with more content. And the nice thing about this Exergame is that you can play it on any exercycle. So if you've got any stationary exercycle at home, just put your MetaQuest headset on. It supports every MetaQuest headset, and just sit on the exercycle and race. The game is called Race Yourselves because you can race against yourselves. You can race against your previous performances. So whenever you play the game, it creates a ghost avatar in the game and you're racing against all your previous performances. And so head to the SideQuest store and have a look at it and let us know how you like it. Thank you.
Our Lighthouse project for Emil was inspired by a problem with the popular augmented reality paradigm, where users experience AR as a window on the world through a smartphone or a tablet. We proposed a new paradigm, the world as support, which facilitates a group experience and puts the user's focus back on the physical space. From 2015 to 2022, we built prototypes of a device we call the AR Magic Lantern, an augmented reality flashlight that implements the world support paradigm. Throughout the development, we tested the prototypes with museum visitors in a collaboration with the Museum of the History of Barcelona. With EU funding through Emil, we have developed a TRL-8 or production-ready prototype of the ARML. It includes an onboard computer, powerful projector, stereo camera for inside-out tracking, audio subsystem, programmable LED illumination, cooling system, and over 90 minutes of battery life. We have also completed an open-source developer platform for the ARML based on Unity 6. To learn more, find our SDK and documentation on the project's GitHub page.
Hello, I'm Melvin Roerdink from the VU team in Amsterdam to give you an overview of Project CAPARE, in which we utilize augmented reality to improve gait and balance in Parkinson's disease. We are nearing the end of the project and we have met all key milestones. First, we developed and implemented a personalized AR cueing protocol for gait training in the clinic, as well as to assist gait during AR exercises at home. Second, we onboarded more than 15 clinics and trained around 40 physios to deliver AR exercises, starting supervised in the clinic and then independently 6 weeks at home. And in the next 2 months, we will be completing a pragmatic randomized controlled trial with a study sample of 100 people with Parkinson's disease to demonstrate its effectiveness for improving gait and balance. And third, we dive deep on AR data science in both lab studies to validate clinical tests with AR, as well as in the field, providing finer-grained and functional outcomes during treatment at home.
Great.
Hello, I'm Adrian from Atlas 5. We're the team in charge of the Aardman Immersive Exhibition project. The goal of our project is to collaborate with Aardman Studios to create a pipeline which would allow animation studios to produce interactive immersive exhibitions more efficiently. By the end of the program, we'll have created a prototype for a Schönbuschip immersive exhibition using this pipeline. We are currently close to having finished development of our pipeline, and we're about halfway through the production of our prototype. We've gone through the layout and animation blocking phases, as well as testing our interactions design and rendering pipeline in real time. We've developed an animation workflow using iClone and universal rigs, and we are implementing 3D Gaussian splatting assets inside of the project. Thank you.
As we are fleshing out the game's story, we introduced a new protagonist, Maria Telkes, who was a real scientist and is introducing the player within the tutorial to the game's story while simultaneously explaining the controls and gameplay mechanics. We settled on a new visual aesthetic and the title Carbon Dreams Land, from which we dove right into the visual development, building new 3D assets and theme park rides such as the Colossus, a giant Ferris wheel with excavator shovels as cabins, or the Gas Coaster, a kind of roller coaster. All those assets resulted in a coherent game world, building a first level together with our core game mechanic, destroying an oil tower and building a windmill while defending it from enemy drones. At the Emil XR event in Bath, we presented the results of the gameplay experience.
Hey and welcome to our latest coopXscape project update. Our product now has an official name, Crew Together XR. But let's have a look into the three main objectives of our project. First, crossplay. We've made great progress on this. Players on tablets and headsets can now team up. Headsets in addition offer enhanced spatial awareness and immersion, making them ideal for remote players. Second, Mission 4. This mission is all about asymmetrical gameplay. The new operator manipulates the environment to assist the fellow space explorers in solving puzzles. Third, Mission 5. This mission features an AI with a split personality. Players solve puzzles while uncovering the relationship between the split AI cores. Our AI-driven dialogue system generates dynamic, character-driven dialogue, expanding variety and cutting production time. We are thrilled how far we've come so far. If you're curious about Crew Together XR, feel free to contact us.
Part of our team went to Bath to showcase our demo. We received lots of good feedback and we're happy with how the event turned out. We have continued improving the data collection up by polishing the design and recording repetitions to receive more data. Our research with Azure Kinect is proceeding and we are constantly solving bugs which occur during development. Currently, the app can play recordings of motion tracking data based on the file names. The XR app now has a pain assessment feature which will emerge if the patient reports feelings of pain. In the future, the completed pain assessment will be sent to the web app to be viewed by the healthcare professional. For now, the feature is still in the development. We are currently in the process of improving the web app's design by adding some essential features which will make the app more user-friendly.
GANIMATEER has been focusing on creating AI tools to assist 3D animation creators. Our first contribution has been the creation of a dynamic 3D animation library, where the creators can generate infinite variations of the supported assets in only a few seconds. We provide an export option for a standard rig format that can be used for retargeting. Other than that, we support common integration-ready formats for our rig, such as FBX and GLB. Our next contribution allows for restyling the captured or generated 3D animation on the fly, supporting widely used styles such as catwalking, airplane, drunk, and imitating Superman.
Hi, this is AI Rodney Mullen from Reality Crisis Finland. Our Intelligent Spatial Computing and XR development platform, IXR, aims to evolve real-world sensing AR functions by developing an AI-driven intelligent layer that reads and understands the surroundings within a specific context. In our case, in the context of skateboarding, the system will detect skatable objects and shapes from the environment, analyze them, and creates environment-based trick suggestions, skate challenges, and game content based on the user's unique physical world setting. Our framework can later be adapted to serve other use cases.
Hi, this is Crew and we are updating you on the progress of our location-based XR performance tools. Over the past few weeks we have been fortunate to have time for development and testing during our first residency at the Residenztheater in Munich. Our main focus has been on improving our animation tool Chorus. As a reminder, we are developing this tool to improve the live animation possibilities for our mocap performers, such as duplicating and repeating previous movements live. As our research continues, we are adding new aspects and features to Chorus. It is now possible for our actors to take on any character in a scene during a performance. This tool also spatializes the sound, adding a dimension of distance and position. In addition, these embodiments can be recorded and played back at any speed. While we are making progress with the research, we are also maintaining our wiki on GitHub. Bye, and see you next time.
Hi, I'm Anne from SenseGlove, here to give you a brief summary of Project Rembrandt so far. Teleoperation enables users to remotely operate robots and interact with diverse environments. Rembrandt, our innovative haptic input device, elevates this interaction with advanced haptic feedback and precise control of humanoid robot hands. We explored various technologies for our toolbox and identified our target user group, shaping Rembrandt's product vision. A key feature of Rembrandt is the active force feedback mechanism, enabling users to feel object stiffnesses. We have developed two-finger TRL6 prototypes with optimized linkages and an integrated force feedback system, along with the first stages of hardware embodiment. We are continuing to refine the force feedback control loop, incorporating our custom force sensing gripper so users can experience the full potential of haptic tele-interaction.
From the last video report, we have made significant progress in the Virtual R3 project. First, the cable-driven parallel robot has been fully operational since the last week of October and is now ready to work with people. Second, we have developed a small-scale prototype to be used in dissemination activities and events such as Stereopsia 24. Work has also been done on standalone communication and integration of the VR glasses, the medical application on the tablet, and the cable robot. In addition, we did two demonstrations. One at the Bath project meeting, which showed a haptic mode of operation in which a person controlled the robot while walking according to their intentions, and another at the Stereopsia 24 event, in which the robot followed the path of a person using data from VR glasses. Currently, we are refining the third mode of operation, in which the robot guides the patient along a predefined trajectory.